Hi, I'm Guo Cheng Guang, secondary one for NS High School. Right now here, we're having a lesson about ordinary differential equation. So in this type of ordinary differential equation, let me just start off with a simple example. But in this example, I'll be finding the homogeneous solution and the particular solution. Then from the particular solution, later on, I'll find more things about it. Alright, so for this example that we're going to start with, we could use d squared y over dx squared, then you add 6 dy dx, then you add 8y, and then from this part it is equal to e to the power of 3x. So this is the part that you have. Alright, in this part, let's take a look. If we are finding the homogeneous solution first, okay, so homogeneous solution, you can represent it with YH. So to find that, that means d squared y over dx squared at 6 dy dx at 8y, this will have to be 0. So this is the case when finding for homogeneous solution. Well, in this case, what we have done before is use characteristic equations. That means we need to let y be equal to e to the power of lambda x. So first derivative of y, lambda e to the power of lambda x. Second derivative of y will be lambda squared e to the power of lambda x. Since you're here in this part only until second derivative, so we only need the second derivative in this part. Alright, then you'll realize in each of the terms you have e to the power of lambda x. So that means you can just straight away ignore that part. And that means for all that you have will be lambda squared, then you add 6 lambda, and you add 8. And this is equal to 0. So then you can use factorization to solve this. So if you directly write out the factorization part, this is what you get. Okay, add 2 and add 4. That means lambda 1, negative 2. Lambda 2, negative 4. So this is just the part that you have. And for YH, it will be C1 e to the power of negative 2x, then add C2 e to the power of negative 4x, then you have a C3 behind here. So wait, no, you don't have this part, because if you have a C3, your C will remain. Okay, so this is the part that you have here. Next will be for our particular solution. Okay, we have already done homogeneous solution. Next part, particular solution, they can combine to the general solution. But general solution we're not having it in this part yet. So yp, that means we just need to take the whole thing. We take the whole thing into it. And the method that we have used before, d squared at 6d, then you add 8. So this method here is the operators method. So we're using operators method in this case. And when we're using operators method, when we're like sort of dividing this to the other side, although in reality we cannot divide it, we're just taking what if we could divide it. Well, then we factorize at the same time. So we're just thinking if we could divide this. So then after that, you'll use partial fractions in this case. Oh wait, partial fractions be what? This is 2 and this is 4. If you directly write, like this, what you will realize is 4 subtract 2, you have 2, not 1. So that means you need half this entire thing. So you need to half the entire part. Then in the next part, you can start to integrate. First part, e to the power of negative 2x. So inside you add 2x, which you get 5x. Then you have to subtract. Here you have e to the power of negative 4x, which then you integrate e to the power of 7x dx. Alright. So here you have 1 over 5 e to the power of, so at last it is still 3x. Then from here you have 1 over 7, which is still e to the power of 3x. So when you subtract these two, you'll have 2 over 35, but 2 will simplify with this 2, that means you'll get 1 over 35 e to the power of 3x. So here is our particular solution. Okay, homogeneous solution, particular solution, we have both found it. So if you want that general solution, I'll just write it here. Okay, so this will be your general solution. Just be aware that here we don't have that constant, since this is for a particular solution. But let's try to find something. We try to experiment a little bit on it. Yp, we take this as a function here. So when we take this as a function, let me just write it here. Use ft. And then we look at this power. What if we sub this power into this part? So then to use f3. Then get 9 plus 18 plus 8. So 27 and 8, it is 35. But wait, you compare with this part again. This is exactly your denominator. So this may seem a little bit strange to you. Well, first of all, this part, we're just assuming that it is like this. Whether is it true? Well, we'll prove it in the next lesson. So in this part, that means whatever you get from here, you can directly use this part to solve it. Like for example, if you change this question a little bit, or a few examples. So here, for example, you directly get d squared, then you add 6d, then you add 9. Then y, and you get e to the power of 4x, like this. So that means, for this part, what you need to put for your fd is just this part. Or if it is multiple choice, you can don't even write this part, you just directly get f4 in this part being equal to, so you're just subbing it in, 16 and 24 and 9. So here you get 40, there you get 49. So here you directly get this, and that means your y particular solution will be 1 over 49 e to the power of 4x. Or if you still want another example, so if you still want another example, yes, I can give another example, for example. So d squared plus 7d, then you add 12. So this is actually quite simple. So if I were to make it a little bit more difficult, okay, e to the power of 6x for this part. So in here, if you don't write fd, so it can just directly be this part. So you just directly need f6. So f6, 36, 42, 12. Then you get 92. So what you get? Wait a second. Wait. This is 78, 90. Miss out that extra 2. So for this part you get 90. So yp will be 1 over 90 e to the power of 6x. So it is already like this. So here we already have 2 examples. So in general, for this part, the general part, if you get f dy being equal to e to the power of mx, what you will directly have is, for your y, particular solution in this case will be e to the power of mx over fm. So this part, it actually works. Well, for this part you can call it like a theorem. Yes, you can call it like that. So it actually works, and if you want to know why does it actually work, well, the proof will be in the next lesson. So this is the general case. Here are actually 3 examples about it. So for this time, we're not going to prove it, just take note, it is in the next lesson. So if you really want to know how to prove it, just go and watch the next lesson. Alright, so I'll be ending this lesson here. So if you like our videos, don't forget to subscribe to our channel. We'll see you in the next lesson. Thank you for your watching.